Good morning, everyone. Hope you are doing well. Till now, we have discussed the general chemistry of Group 15. In today's session, we will discuss the preparation and properties of nitrogen and ammonia. So, let's begin. Dinitrogen. It was discovered by Daniel Rutherford in 1772. As nitrogen occurs as a diatomic molecule, so it is also known as dinitrogen. In laboratory, nitrogen can be prepared by three methods. So, let us look at the methods of preparation of nitrogen. The first method is by thermal decomposition of ammonium nitrite. Aqueous solution of ammonium chloride reacts with the aqueous solution of sodium nitrite to give ammonium nitrite and NaCl. But NH4NO2 is unstable, so it readily decomposes into free nitrogen. Small amount of nitrogen oxide and nitric acid are also formed in this process. These are removed by passing the gas through aqueous sulfuric acid containing potassium dichromate. The second method is by thermal decomposition of ammonium dichromate. Ammonium dichromate decomposes thermally to liberate free nitrogen along with water vapors and chromium oxide. The third method is by thermal decomposition of sodium or barium azide. An azide is a compound which contains N3, means all the three nitrogen atoms are linked to each other. Here we can see that sodium azide decomposes at 573 Kelvin to liberate nitrogen gas and free sodium metal is obtained. Similarly, barium azide also decomposes thermally to give nitrogen gas and barium metal is liberated. Now let us look at the properties of dinitrogen. First, some physical properties. It is colorless, tasteless, and non toxic gas. Though during high concentration of nitrogen, animals die. That is due to the lack of oxygen. It has two stable isotopes, nitrogen 14 and nitrogen 15. It is very slightly soluble in water. It has low freezing point 63.2 Kelvin and low boiling point 77.2 Kelvin. It is adsorbed by activated charcoal. And now let us study the chemical properties of nitrogen. It is neutral towards litmus. Reaction with metals. It reacts with metals on heating to form the corresponding nitride. For example, with lithium it forms lithium nitride, with calcium it forms calcium nitride, magnesium nitride, and with aluminium it forms aluminium nitride. Reaction with nonmetals. Nitrogen reacts with hydrogen at 700 Kelvin and high pressure of 200 atmospheres to form ammonia. This reaction is used in the manufacture of ammonia by Haber's process. Nitrogen reacts with oxygen at very high temperatures ranging from 2000 to 3000 Kelvin to give nitrogen oxide. This reaction forms the basis for the production of nitric acid. Nitrogen reacts with aluminum oxide in presence of coke at around 1273 Kelvin temperature to give aluminium nitride and carbon monoxide. Nitrogen reacts with calcium carbide at 1273 Kelvin temperature to give calcium cyanamide and coke. This mixture, calcium cyanamide and coke, is called nitrogen and it acts as a very good fertilizer. Calcium cyanide undergoes hydrolysis to give calcium carbonate and liberates ammonia gas. Active nitrogen. Nitrogen in its atomic form is highly reactive. It is called active nitrogen. Active nitrogen can be prepared by passing electricity through nitrogen gas at very low pressure of 2 mm Hg. Active nitrogen reacts with almost all the elements and compounds. One example is it reacts with acetylene gas to give cyanogen and hydrogen gas is liberated. Now some uses of dinitrogen. It is used in the manufacturing of nitric acid, ammonia and calcium cyanamide. It is used for filling electric bulbs to reduce the rate of volatilization of the tungsten filaments. It is used as an inert diluent in reactive metals, in reactive chemicals. It provides an inert atmosphere in iron and steel industry. It acts as a refrigerant to preserve food, biological materials, and in cryosurgery. Nitrogen thermometers are used to measure high temperatures. It acts as an antioxidant. The next compound is ammonia. Let us study the manufacturing of ammonia. Commercially, ammonia is manufactured through Haber's process. Nitrogen gas reacts with hydrogen gas in a proportion of 1 is to 3 in the presence of aluminum oxide and potassium oxide as catalyst, temperature of 700 Kelvin and a very high pressure of around 200 atmospheres to yield ammonia. The enthalpy of formation of this reaction is minus 92.4 kilojoules per mole. By looking at the reaction, we can very well understand that the reaction is reversible, exothermic, and occurs with decrease in volume. According to Le Chatelier's principle, the favorable conditions for manufacture of ammonia are low temperature. As the reaction is exothermic, so decreasing the temperature will lead the reaction to form more ammonia and liberate more heat. But there is a problem. We cannot decrease the temperature to very low because the bond dissociation enthalpy of nitrogen is very high. So decreasing the temperature to a very low will not will prevent nitrogen from dissociating. Hence 700 Kelvin is the ideal temperature for this reaction. Next is high pressure. We know that pressure is directly proportional to the number of moles. In this reaction, the number of moles of reactants are higher than the number of moles of the product. So, increasing the pressure will cause the system to shift in the forward direction in order to regain its equilibrium condition. We can look at the structure of ammonia. The HNH bond angle is 107.8 degrees and the bond length is 101.7 picometers. Addition of catalyst further increases the rate of reaction. Now let us look at the physical properties of ammonia. Ammonia is a colorless gas with characteristic pungent smell or ammonical odor. It is lighter than air. It is highly soluble in water and its solubility may be up to 1000 times. It can be easily liquefied by cooling under pressure. Its boiling point is 239.6 Kelvin and the freezing point is 198.4 Kelvin. Now let us study the chemical properties of ammonia. Basic nature. It is highly basic in nature due to the presence of lone pair or nitrogen atom, which is easily available for donation. Ammonia readily dissolves in water to form ammonium hydroxide, which dissociates into ammonium cation and hydroxyl anions. Ammonium hydroxide is a very weak base. Reaction with metal salts. Ammonia reacts in its aqueous form with ferric chloride to give a brown precipitate of ferric hydroxide. Similarly, it reacts with aluminium chloride to give a precipitate of aluminum hydroxide, which is white in color. These reactions are important for qualitative analysis of group 3 cations, as ammonium hydroxide behave as a group reagent and it the precipitates the precipitate indicates that group 3 cations are present. Ammonia acts as a Lewis base, as ammonia lacks d orbitals and its atomic size is very small, so it has a very large electron density. Due to this, it can donate its electron very easily to the Lewis acids or any other desiring species. Hence, it acts as a Lewis base. In this reaction, BF3 is a Lewis acid and NH3 is a Lewis base. So, both of them react together to form an addition product or an adduct. Ammonia also reacts with the D block elements like copper to form complex ions. Oxidation. Ammonia undergoes oxidation in presence of copper oxide to liberate free copper and free nitrogen is also liberated along with water. Ammonia undergo oxidation by direct combination with oxygen at 500 Kelvin and 9 bar pressure. Here, platinum and rhodium gauze act as the catalyst. In this reaction, nitrogen oxide is produced along with 6 molecules of water. Action of halogens. The reaction of halogens with ammonia will depend upon the concentration of ammonia and halogens. If ammonia is taken in high concentration, then free nitrogen is liberated along with the salt of halogen. If the halogen is taken in high concentration, then corresponding hydrohalic acid is produced and nitrogen halide is produced. For example, we can see that 8NH3 plus 3Cl2 gives you 6NH4Cl plus N2. In this reaction, the ammonia is taken in excess. In the same reaction, if chlorine is taken in excess, then the products are NCl3 plus 3HCl. With bromine, ammonia reacts in excess to produce ammonium bromide and free nitrogen. Ammonia reacts with iodine to give NH3.Ni3, a sort of addition product. NH3.Ni3 is relatively unstable and it readily decomposes to liberate free iodine. Action of metals. Ammonia reacts with alkali metals at 575 Kelvin to form alkali metal amide and free hydrogen is liberated. For example, with sodium it gives soda amide and with potassium it gives potassium amide. Reaction with CO2. Ammonia reacts with carbon dioxide at a very high pressure of 220 atmospheres and 453 to 473 Kelvin temperature to form ammonium carbamate, which undergoes dehydration on further heating to form urea. Liquid ammonia acts as a non-aqueous solvent. It dissolves organic compounds. 2NH3, when dissolved in water, forms NH4 plus and OH minus, but when it undergoes self-ionization, then it forms NH4 plus and NH2 minus. Identification test of ammonia. Ammonia reacts with Nessler's reagent in presence of a strong base to give a brown precipitate. This brown precipitate is actually the iodide of Milan's base. Uses of ammonia. Ammonia is used as a refrigerant in ice factories and cold storage. It is used as a cleansing agent for removing grease. It is used as a laboratory reagent. It is used in manufacturing of nitric acid. It is also used in the manufacturing of nitrogenous fertilizers like urea, CAN, etc. So this is all for today. Tomorrow we will discuss the preparation and properties of nitric acid. Till then, stay home, stay safe. Thank you.